Welcome back to another exciting chemistry lesson. In this lesson, we are going to learn about structure of an atoms. Well, let's look at this structure of an atoms right here. So here we have a basic structure of an atoms. Of course, this is a Bohr model. This is not the realistic what an atom looked like, but this is a representation that allows us to understand where the electron are located and where the nucleus is located. Well, each atom consists of three types or made of three types of subatomic particles, and each one of them has specific charge or mass values. So here we have neutron represented by the letter N, then proton P, and lastly, of course, we have electron E. And in addition to that, it has the electrostatic charges on top of it. For neutron, think of neutral. And then for proton, think of positive. P for positive, and electron think of negative. And now, in terms of location-wise, if you notice, I drew this little, supposed to be even tiny dot that represent a nucleus. So basically, a nucleus consists of what? Well, a nucleus consists of neutron and proton. So what does that tell you? Well, if you have zero charges and positive charges, it has a net charge of positive. So the nucleus always has a positive charge. That's why we have this big positive right there. And then the charges for electron again is negative. Now let's go to the mass. The mass of each neutron is 1 AMU, atomic mass unit. So AMU. And then proton is also 1 AMU. But for electron, it is so tiny and small, it doesn't have any mass at all. So let's look at this, okay? So here you have an atom nucleus, consists of positively charged proton and neutral neutron. So therefore, the overall charge must be positive. Now this positive is very important because we realize that when you have a positive, right, what does that do? It attracts to the opposite charges of the negative. So keep that in mind, okay? Now we have to realize this. Notice how I drew this to be a very tiny little volumes, alright? But it has all the mass. See, this makes up almost 99.9% of the mass of an atom. But it is extremely small. What does that tell you when you have heavy but small? Well, that tells you that the density of the nucleus is extremely high, okay? And that's the only way it works. You have a very tiny items, but it's extremely heavy. Therefore, it must be really dense. It has a lot of mass in it. Well, look at the electron. Look how much volume it took, right? How much space it takes in terms of surrounding the nucleus. So let's look at an electron. Notice electron take up most of the space, right? The volume is so huge compared to the nucleus. This region in space where we have this high probability of finding electron of that particular atom is called an electron cloud. So in here we have the electron cloud. So this whole entire space around the nucleus is called electron cloud. Now notice electrons are extremely tiny. It doesn't have any mass at all. But in the end, it makes up most of the space of an atom, like 99% of the space of an atom. Now, what do you call the space? What is in here? Well, in here between the electron, they are just empty space. So, empty space. Now, think of empty space. We're not talking about the empty space in this room, no. We're talking about the empty space at the atomic level. At the atomic scale, we're talking about the scale where it's so tiny. We're talking about 10 to the negative 9, 10 to the negative 10, or even smaller than that. We're talking about that tiny scale that we can't even visualize it. So we are talking about that empty space, okay? We're not talking about the space in a room. We're talking about the atomic scale space. And the majority is empty space around the nucleus. So an atom consists of mostly empty space. Now let's go down and look at another factor, and this is called valence or outermost. So the word valence is basically outermost. Well, what does that outermost mean? Well, you look at this electron right here, right? They are located in specific rings. This ring is the outermost ring. or the better term is orbit. Okay, and of course all the one inside are considered inner. Okay, inner electron. So what's so special about the outermost electron? Remember, we talked about electrons are very tiny and they're a very fast moving object. So therefore they can be easily stolen or gained by an atom. So that is one of the most important factors why we have so many different chemicals in this world. That's because electrons are allowed to transfer from one atom or even share between atoms as well. And that is the heart of chemistry, transferring electron and sharing electron to create completely unique different chemicals that different substance and different chemical properties that we use in our daily life and affects every living things in this whole entire universe. So that's the power of valence electron, and we will learn that later in this chemistry class. Let's talk about neutral atoms. Well, we talk about neutral atom in terms of zero charges, right? So we have zero charges. So what does that tell you? Well, if it has zero charges, that means the positive and the negative cancel out. So therefore, the number of proton must equal to the number of electron. Isn't that nice? So the total positive must equal to the total of negative. So the number of electron and each proton in specific atom for any element on the periodic table is the same, which is the atomic number. And we will look at that carefully. And then we also have another type of atom known as ions. So ions are a specific type of atom that have lost or gained electron. And we talk about how electrons can be lost or gained easily by atoms because this process allows them to be more stable, okay? For example, if we have an ion that has a positive charge number, that number indicates how many electrons have lost, okay, by that specific atoms. Now, on the other hand, if it's negative, if it has a negative charge number, that negative charge number indicates how many electrons have gained by that specific atom. Now, think about it. Why does a negative has a gain values and a positive has a loss values? That's because look at electron is negative. So if you are gaining more negative electron, you become negative. If you're losing those negative, you become positive. And that's the logic behind it. So let's do an example problem. An oxygen atom from a periodic table, remember every atom from the periodic table is neutral, has what? Well, oxygen is right here. Remember, this is the atomic number, right? And this number is equal to what? That number is also equal to the number of proton as well. So in this case, it has how many proton? It has 8, and therefore it also has 8 electron as well. Now when it becomes an ion, it has a formula of O2 minus. You see that 2 minus right there? That minus tell you that it has gain, right? And how many? 2 electron. So in this case, it has gain and then the total of 2 electron. So it's no new total of electron. What is 8 plus 2? That's 10. Isn't that easy? So here is coming from 8 plus 2. 2 is from the neutral atoms, okay? Original number. Now let's look at another one. Sodium atom from a periodic table. Here's sodium. Has what? It has 11 proton right there. And then, of course, it's going to be 11 electron because, again, it's neutral. It's the same. When it becomes an ion, it has a formula of Na+. Well, it's missing a number. Well, what is the number that always defines itself? In this case, it has to be number 1. So it has a loss. How many? A total of 1 electron. So 11 minus 1. What is 11 minus 1? Well, that turned out to be what? Equal to 10. There you go. So let's go check our answer. We have oxygen, right? So that is 6. So let's go check our answer. We have 8, 8, and it has what? It has gain, total of 2 electrons, so the total is 10. There you go. Submit and finish. Isn't that nice? Now let's go check another one. Now let's go check the other one with the sodium. Well, we know sodium has 11. This one is 11 when it's neutral. And it has loss, okay? And then a total of 1 electron lost. And how many electrons does it have now? 10. And that's the logic behind of using the periodic table to determine the number of electron, proton, but most importantly, determine how electrons are being lost and gained by looking at ions. And what do we learn about those ions? Because that is the heart of chemistry. And as always, if you have any question, take a picture of your question and answer, put it in the forum, and we will help you from there. And we'll see you next time on another chemistry lesson.